Now, in the previous video, we've already seen as to why we need to adjust this length of the stub, okay? Because our main task is to adjust the value of the susceptance of your stub to be equal and opposite to the value of the susceptance of the transmission line. And the only thing that we have in our hands is the length of the stub. All other terms are constants and we can't change them. So what we do is we can adjust the length of the stub to be equal to this particular expression, and then we will achieve what we want, which is get BS, which is the susceptance of the line, to be equal and opposite to BSC, which is this is of the stub and this is of the line. Okay? Now, the susceptance of the line at D is then cancelled and the line appears to be terminated in a resistance of value R0 at that point. Now, what we're saying basically is we've placed in our stub, okay, we've placed it on the load side of the voltage minima. S2 is the distance of the voltage minima from the load, S1 is the distance of the stub from the load, and D is the distance between the voltage minima and the stub. So, if we are looking at it in terms of the transmission line, from the generator end till this point it is going to appear like the line has been terminated in its characteristic impedance of R0. Okay, now there is a small portion over here, which means that this is going to act like a smooth line with no reflections. That's what is the definition of a smooth line. There is no reflection, only incident wave. Okay, and complete impedance matching from the generator end till this point. But here you are going to have certain amount of reflections because this line is not matched. So you're going to have losses over here. But you think of it in terms of a line which is a few thousand kilometers long, okay, and this is a very small distance. It's going to be less than lambda by 4, because here is a voltage minima which is closest to the load, okay, and we don't have a voltage maxima even. Okay, so which means it's a distance, the distance between a voltage minima and a maxima is lambda by 4, which means that this is a distance that's going to be shorter than lambda by 4, which is a very small distance, and you can actually ignore the losses that could be, that are involved at this particular point. Okay, so this here there is going to be some reflection, but those can be ignored. Now, my next thing is, why are we placing, or would it be possible to place this particular stub on the other side of the voltage minima? Okay, it is possible. What we can do basically is, if this is my transmission line, this is the load, okay, and let me say this is a voltage minima. If this is a voltage minima, instead of placing the stub at this point like we've done over here, which means on the load side of the voltage minima, we could also place the voltage minima over here on the generator side of the load. Sorry, on the generator side of the voltage minima. Okay, so instead of placing it, which means that now my distances would change slightly. While this is continuing to stay S2, this is going to be a distance of S1, and this is going to be the distance of D. Okay, so what we are going to have then is that S2 is going to stay the same. Okay, D is going to be equal to S1 minus S2, unlike in this case where D is equal to S2 minus S1. Now here D is going to be equal to S1 minus S2. Okay, or in other words, we can also say that S1 is going to be equal to D plus S2, or we could also say that, D is going to be equal to S2 minus S1. Okay, so these distances are going to change for us slightly. Now, a short-circuited stub is preferred to an open-circuited stub. Now, all throughout this derivation, we've looked at a short-circuited stub. But like I've said before, we could also have an open-circuited stub which would be this line, and it would be open-circuited instead of being short-circuited. This is short-circuited, right? It could be open-circuited. It could be a stub which is open-circuited. Okay, but there is a reason why we generally prefer to make use of short-circuited stubs. A short-circuited stub is preferred to an open-circuited stub because of greater ease in construction. Now, to make something zero is much easier than to make something infinity. In other words, our short-circuit conditions is that ZR has to be equal to 0, while our open-circuit conditions is that ZR has to be equal to infinity. Now to get that, which means that you have to get really high insulation, okay? And you have to make the resistance extremely high, close to infinity, which is a very difficult task, and besides that, you're going to have incurred costs. So in order to make this a completely very high, you would require a lot of insulation to be used, okay? So so that's greater ease of construction for a short circuit, and because of the inability to maintain high enough insulation resistance at the open circuit point to ensure that the stub is really open circuited. That's a very difficult task. Now a short circuited stub also has a lower loss of energy due to radiation, since a short circuit can be definitely established with a large metal plate, effectively stopping all field propagation. This is especially true for a coaxial line where the short circuiting plate can be made to seal the line completely. Okay, so in every way the short circuit is much easier to carry out, okay, in comparison to the open circuit. Now that I've told you this, told you how this works, okay, what I want you all to do now is give me an expression for L dash, okay. Now I've written an expression over here. I want you all to write the derivation by yourselves. While the value of S1, D and S2 is not going to change, from what we've done previously, okay, I'm not talking about an open circuit, I'm talking about a short circuit. I want you all to find out the value of L dash for a short circuited line which has been placed on the generator side of V min. Okay, so the next task is to find out the value of L dash. I've written these expressions over here. I want you all to write the derivation for this expression or verify. You don't even have to write this expression. What you will have to start off with is you first start off with, we already know that S1 is going to be equal to D plus S2. You put in the value of S1, you put in the value of D, and you put in the value of S2. Okay, accordingly make your changes. Then, as we have already done before, follow the same steps, which means that BS has to be made equal and opposite to BSC. Okay, so do exactly the same thing, but in BSC, instead of having G naught cot of beta L, you have it as L dash, where this refers to stub placed on generator side of V min. Okay, so do that. This is the assignment for you all. Okay, so you have to complete this task, and then you have to tell me what will be the value of L dash. Now you might arrive at this expression, and if you arrive at an expression which is slightly different from this, it's fine, but do upload it into the classroom.